So this is our lecture number 4 and we will start our chapter number 3 today. Chapter number 3 name is properties of pure substance. While in this lecture we will learn how to use steam tables and also we will be seeing how phase changes. These topics are very important and relevant to the thermodynamics course because also this chapter is called the basics of thermodynamics. All the basics rely on this chapter because from now on we will be using our thermodynamics tables or steam tables throughout our thermodynamics course. And if you want to understand these topics, you won't be able to solve some certain numericals. So here we have phases of a pure substance. So pure substance can be found in solid, liquid or gas. So one thing that makes them apart from each other is their molecular arrangement. Solids are very compact while liquids are less compact, and gaseous states or gaseous molecules are very far apart from each other. So here we have a graph which is temperature versus volume graph. So here we have the temperatures and here we have the volumes. um, so first off we have compressed liquid, then we have saturated mixture, and after that we have saturated vapors. So what is a compressed liquid? The liquid that is not about to vaporize is called compressed liquid. So here we have a liquid that is not yet vaporized, and after that process from 1 to 2, and this is compressed liquid, and 2 to 3 we have saturated mixture, and after 2 we will be seeing that our liquid is slowly converted into vapor form. And when it reaches 4, the point 4, it will be completely vaporized, and after that the temperature of vapors also increases. So this state is completely vaporized, so this is partially vaporized, and this is completely liquid. So here we have 1 to 2 compressed liquid, which means that our process is not yet started, but from point 2 it is called saturated liquid. So point 2 here we have is saturated liquid. And what is saturated liquid? The liquid that is about to vaporize. So from 2 is saturated liquid, and after that it will be called saturated mixture. From 1 to 2 we have compressed liquid, and point 2 is saturated liquid, and now we have saturated mixture. So saturated mixture starts from 2 and ends up on 4. Throughout this line this is saturated mixture, in which we will see that how our liquid starts to vaporize and ends on being completely vaporized. So here we have fully liquid, and at here at point 4 we have completely vaporized form, and in between we have a mixture of liquid and vapors. So here we knew that stage 2 is called saturated liquid, and the stage 4 is called saturated vapor. So what is a saturated vapor? When our liquid is completely vaporized, then we call it saturated vapor, and after this process it is called superheated vapor from 4 to 5. So from 1 to 2 we have increased our heat, and 2 to 4 we are giving a constant heat, and after that we are also adding heat to the system as well. So here we have different stages, but one thing that is in common is pressure. Here we have the same pressure throughout the process, but our temperature at the beginning is increasing, but in between it remains constant, and at the end we also increase it. So temperature is actually varying throughout the process, but pressure is constant. So at start we have 1 atm pressure, and the temperature is 20 degrees Celsius. So this is the start of our process, and our uh, our water is in liquid phase, which is also called compressed liquid. So we increased our temperature to 100 degrees Celsius, our water exists as liquid that is ready to vaporize. So our water is ready to vaporize, which will be called saturated liquid. And after that, we have kept our temperature constant, but we can see with time our liquid is here, and some of the liquid is vaporized, which is here. So this state will be called saturated liquid vapor. And this is a state where completely all our liquid is completely vaporized, so this will be called saturated vapor. And at the end, as more heat is transferred to the system, we have all the vapors are actually we can say vaporized, but still we are given heat and we are increasing our heat. We in and end result was, as more heat is transferred to the system, temperature of the vapor starts to rise, and this will be called superheated vapor. So when pressure is given to us and our substance changes its phase at some temperature, then that temperature will be called saturated temperature. So actually what happens that when we have steam tables, either we are given pressure or either we are given temperature. So we will see we have a table there, and from one value we can find the another value. So if you are given pressure, then the temperature that we will be found there is will be called saturated temperature. The same goes for that, like if you are given temperature and we are finding pressure, then that pressure will be called saturation pressure. For example, here we have a pressure given, which is 101.325 kilopascal. So at that on table we will see what will be the value of temperature. So that temperature will be called saturated temperature, and that value will be 99.97 degrees Celsius. Same goes for 99.97 degrees Celsius when will be given to us when we will check our table. The value for pressure will be 101.325 kilopascal. So that pressure will be called saturated pressure. So in tables we have pressure table, we have temperature table. So if we are given temperature table, and then if you are given temperature, then we will see the temperature table. So here we have given temperatures that you may have been given, like for example you are given 20 degrees Celsius, then our saturated pressure will be 2.34 kilopascal. So this is how saturated temperature or saturated pressure is found. So here we have um, pressure versus temperature diagram. So here we can see that when we are increasing our temperature, our pressure is also increasing. So we have studied 5 properties. First property was compressed liquid, and after we have saturated liquid. And the third was saturated liquid vapor, and fourth is saturated vapor, and five is superheated vapor region. But the three major process that are very important is compressed liquid, then we have a different state which is saturated liquid vapor, and the third is superheated vapor region. So these are the three forms. So at the beginning we have compressed liquid region, and after that we have a saturated liquid vapor region, and the third we have superheated vapor region. So at the beginning we know we have compressed liquid, and at some time with heat our this dome is actually saturated liquid vapor, but after this whole side is superheated vapors, and on the peak point is called critical point. So this is a point where half process is done. So we already know that the saturated mixture was the straight line in between compressed liquid and superheated vapor. So saturated mixture, we know that we have our liquid is converted into vapors. So The critical point actually is defined as the point at which saturated liquid, we know that what is saturated liquid, and saturated vapor states are identical. So what does that mean? So this means a critical point is a point in saturated mixture at the center, so where we have 50% liquid, and on the other side we have 50% vapor. So this is the center point. So this is called a critical point, and after that, after critical point, our vapor starting increasing, and the liquid is less compared to vapors. So in a percentage, now we can say critical point is a point where 50% liquid is present in a container, and 50% vapors are present in a container, so it is a complete equilibrium state. So here we have enthalpy, which is denoted by H, and also with capital H as well. So we know that why this is small h and why this is a capital H, because this is with per kg or per unit mass, and this is without or excluded with mass. So what is enthalpy? Enthalpy is actually combination of internal energy and the product of, here we have pressure and here we have volume, so the product of pressure and volume. So if you combine them together, this will give us a enthalpy. So from now on, we will be studying property tables. So what is a property tables, in which we can see for any substance we have different properties written there. For example, temperature, pressure, internal energy, enthalpy, and a lot more. So all the properties will be given to us. So how that was made? Actually, many scientists made that with a lot of experiments. After a lot of experiments, a lot of calculations, they made a property table, and till date this property table is being used. So this made it very convenient to use for numericals and for another experimental purposes. So commonly used property tables are A1, which is to find the molar mass, gas constant, critical point properties. So, and table E4 is saturated water temperature table. So whenever the water will be given to us, we will use table A4, A5 or A6. So this will be for saturated water, or when the temperature is given to us, and A5 will be used when pressure will be given to us, and A6 will be used when superheated water will be given to us. So how we will know superheated is given to us? When we won't be able to find properties on these two tables, then we will know that our value relies on the superheated region, because at first it will be our property, it will be our priority to use the temperature table. But when the value will not be found, then we will go for pressure table. And also when we can't find the value here, then we will move toward the superheated vapor. And A7 is compressed liquid water, very less used, and A4 to A7s are called steam tables. So from A4 to A7 we have steam tables. So here we have a table. This is only a part of a table, so we can see there's temperatures first written here. So this is in table number A4, which is temperature table. So temperature is written here, we have pressure here, so we have saturated liquid, and here we have saturated vapor. So in between we have a saturated mixture. So saturated mixture values are not given to us, but we can actually find it through a formula. Here we have the formula for saturated mixture, difference between Vg and Vf. So saturated liquid is Vf and saturated vapor is Vg. Saturated vapor is where 100% or completely liquid is vaporized. So in between saturated mixture lies. So in order to find the value of VFG, so in between them, how we'll find that VFG is equal to VG minus VF. If we subtract the value of saturated vapor with a saturated liquid, then we will find our VFG, which is saturated mixture. So here we have the complete table number A4, which is saturated water. For water we use that for, and this is our temperature table. So here we have all the temperature mentioned. For example, if someone gives you the given value will be 10 degrees Celsius, then you will open the table number A4 and they will give you a saturated water at 10 degrees Celsius. Then you can find the pressure. You can also find the value of any liquid you want, specific volume, any specific volume you can find that. And you can also find the internal energy value, enthalpy value, entropy value. You can find a lot of values here. So these all values are in per unit mass. For example, here we have specific volume, here we have specific internal energy, here we have specific enthalpy, here we have entropy. So at for here we have saturated liquid, here we have saturated vapor, and here we have saturated liquid. And in internal energy, the value for saturated mixture is given to you, and here we have saturated vapor, then all so on, and they all have the same pattern going on. So by means that any in any numerical, any value will be given to us, we can find any property we want. The same goes for the pressure. Any pressure will be given to you, we can find any value we want for the for solving our numerical further. So for given pressure we can find the saturated temperature and all out any value we want. The same goes for the HFG value, which is enthalpy of saturated mixture. How to find that? The same we did for the specific volume. Here we will be, this will be our Hg and minus Hf. So the G represent the saturated vapor, and F represent the saturated liquid. So if we subtract that, then we will find the value of saturated mixture. So here we have a saturated liquid vapor mixture. So how we will know the quality, or how we will know how much vapor we have or how much liquid we have remaining in that category, because this is a complete from saturated liquid to saturated vapor, from stage 2 to stage 4. We have a mixture, so we want to know the quality, how much we have vapor present in that stage, in between 2 to 4, any certain points we want to know what is the quality, exact quality we are at, how much percent we have, 30% vapor or 40, 50, 60, 70. So we want to know that value. So that value will be, or quality will be known as X. So X is equal to M vapor divided by M total. And how M total will be known? M total is equal to M liquid plus M vapor. So M is mass, so we can get the value of X like that. While here we also have another formula for that, we will check in that slide. So when we are talking about a saturated mixture, the quality has very much significance. But when you're talking about compressed liquid or superheated vapor, it does not mean anything. Why is that? Because in saturated mixture, our value is varying in between 0 to 1. We can consider this as 0% and 1 is 100%. So our saturated vapor mixture or saturated mixture, our value is actually varying in between 0 to 100. But at the start, in compressed liquid, the value is 0, and at the end, at superheated vapor region, our value is 100%, because 100% converted into vapor. So it explains that how our liquid is converting into vapor form. So 100 means that 100% liquid is converted into vapor, and if 70 or 0.7 means 70% of the liquid is converted into vapor. So now 30% is left, which is liquid form, and 70% is in vapor form. So that's why the value only matters for saturated mixture, and because it is constant for compressed liquid, which will be 0, and 1 for the superheated vapor. It can be more than that because we know 100% is the maximum limit. So the quality of a system that consists of a saturated liquid is 0, and the liquid of a system containing saturated vapor is 1, which is 100%. I just explained that line to you already, so there's no need to explain that again. In saturated mixture, quality can serve as one or two independent intensive problems needed to be researched. So let's skip that point, it's not necessary at all. So actually it means that VG explained to us as saturated vapor, and this VF is saturated liquid, and in between we have our saturated liquid vapor form, which is called V average, or like VFG is our saturated liquid form, which can be described as VAVG, V average, which means there is no need to get into the derivations because they aren't necessary from the exam point of view. So here from this derivation we can find the value of x, which is our quantity. So after the derivation we got this formula, which is V average. This value will be given to us in the question, or either when it is not given to us, and if we know the remaining factor, then we can find the V average, which is volume per kilogram. And if we want to find the value of quality, then we will rearrange our equation, and this will be our final equation, and V average will be given to us. Vf can be found from the questions or from the table, and Vfg can also be obtained by subtracting the Vf value from the Vg, which is Vfg is equal to Vg minus Vf. And here we have the same goes for the V average. Only factor that will be changed here will be the internal energy. So if we want to find it through internal energy, our value of quality, then our here we will change V to U. And if you want to find the value of x through enthalpy, then we will change our formula to h. So all the formulas are applicable to find the quality. So this is a universal formula, and we will be using that. For example, if you want to find the value of x through enthalpy, then here will be h average minus hf divided by hfg. And if you want to find it through internal energy, then here will be u average minus uf divided by ufg. So this is how we can find the value of our quality, or either the value of v average, u average, or h average from these formula. So here we have superheated vapor. How will we know that we are in a superheated region? So for that there are some conditions that are given to us, and even any one of the conditions is satisfied, then you can say you are in a superheated region. So either you have low pressure, which is your pressure is less than saturated pressure at any given temperature, or higher temperature, which means your temperature is more than saturated temperature at a given pressure, or higher specific volume, or higher internal energy, or higher enthalpy. So for that you can say that you are in a superheated region, and you will look into table number A6 for the values you need to find. So here we have a superheated table, which is table A6, Here you have the temperature. So in table A4 your temperatures ends on 120 degrees Celsius. So after that, here we have the values till 1300 degrees Celsius. And here we have the pressure mentioned: 0.01 megapascal, 0.05 megapascal, 0.1 megapascal, 2 megapascal, so on. We have a lot of values here. Apart from that, we have here volume, specific internal energy, specific enthalpy, and specific uh, entropy. So there are two things that will make you identify that you need to check your superheated table. First, if temperature is given to you, and for example 150 degrees Celsius is given to you, then you will look into table A4 and see that your table ends on 120 degrees Celsius. So you know that uh, I'm in the wrong table. You need to see the table number A6 for that, and you will find the values here. And the other thing is, you can see the pressure as well. If pressure is mentioned, and then you will see that 150 kilopascal is the last pressure that is mentioned on the table. And here we have pressure mentioned megapascal, which is greater than kilopascal. So you can see that table as well in that case. So here are the conditions for the compressed liquid, because sometimes they ask you to write the region in which you are. Either you are in compressed liquids, superheated vapor, saturated mixture, or any other. You need to write that. For that, these conditions are very important. So any of the conditions that is satisfied, then you can say you are in a compressed liquid or superheated region. So there are higher pressure, lower temperature, lower specific volumes, lower internal energy, and lower enthalpies are the conditions. If any one of them satisfies, then you are in compressed liquid region. So they can also be treated as a compressed liquid may be approximated as a saturated liquid at a given temperature. So sometimes our values are so much near to each other. For example, if you see the table number A4 and the table number A7, the values are very close to each other, so we can approximate it as a saturated liquid at a given temperature. So this is table number A7, which is compressed liquid water. Here we have the pressure of 5 megapascal to the 50 megapascal. So if your pressure is too much high, like here, 5 megapascals means that 5000 kilopascal. So it's a very big value. So for that, if your pressure is not in the table A6 as well, then you will look into table A7. So here we have the temperature and here we have the pressure. There are some conditions that we just studied, and if any condition that is satisfied, then you will look into table number A7. So here it is written: when compressed liquid is approximated as saturated liquid, A4 must be used. So how does that happen? For example, here we have 20 degrees Celsius given to us, and if we see the VF value is 0.01002. So if you look back into the table A7, you will see that the value is very near to that. So here it is written that in such case, we must use this table instead of using A7. In some numericals, you may need to specify your region as well. So for that, this table is given to you. This won't be available. You need to memorize this, or you can understand this. These are very easy because you will be given a lot of data to identify that. For here we have temperature, pressure, all the properties mentioned. Here we have the states mentioned, and here are the conditions for that. If you memorize them, it will become easy for you to solve the numericals. So this is our end of the lecture. we have studied all the relevant things. In the next lecture we will be covering numericals.